We are Group 45 and our topic. We are Group 45 and our topic is machine learning based object identification in biological images. And I'm Suyuan Liu. My team members are Zhehan Yang and Shaojie Shi. We are all electrical engineering.
The background of this project is bioimage method offer powerful solution for image analysis task. However, most of image analysis algorithms can only be used on specific biological assays. If we want to use the algorithms to analyze the different objects, we should reprogram the software. Machine learning is a effective way to solve that problem. We are interested in identifying objects with variable and irregular shapes in image taken in biological studies. In this approach, the user just gives a set of examples. The machine will automatically infer the rules out to discriminate the classes. Then a computer program may learn how to identify these objects and their variations in new images. That way can help user analyze different kind of objects by one machine and one algorithm. Our problem is identifying and counting objects with variable and irregular shapes in images taken in biological studies. Example, we can use our program to count the neurons in a hippocampus. Those two pictures show that the neurons in hippocampus.
The things we do in short term can make the biological image classification more efficient because now the biological image classification is that use one kind of program to classify one kind of biological image, so it's not flexible. So that we can make that more efficient and flexible, and into not just adjust the program to adapt the images. So we can use this program to classify all kind of image, even the other aspect of image classification, not only in the biological image aspects, but all can to identify the cars in the road. How many we can count how many cars in the road. So that's the long term we contribute to. Now let's talk about our design process. The things that we have been already is that learning the basic biology knowledge and the method of machine learning. Then we try different language and decide the language of the program. And then we try some different image processing method and try some different algorithm of the program can identify the elements currently. The things we need to be finished is that choose the most suitable method and write the entire program and training the program to make sure it have learned how to identify the neurons in hippocampus. Then test the program which have trained with other images. The things we are adding is that trying some other different image processing method and trying some other different algorithm of the program to identify the elements currently.
The constraints of our project are image clarity, objects overlap, and the size of image. If the objects overlap or the image is not clear, the program will not recognize the objects correctly. The objectives of our project are speed, which means the running time of our program should not be too long. Precision means that the output should be correct. Easy to use, which means that the user can learn how to use that quickly. Variation, which means that program can be used in identifying other objects. Classification and counting mean our project can output the number of the objects which we need. Functions are classification and counting. The means of our project are convolution neural network, region proposals, and faster RCNN. Requirements and assessment metrics. The possible methods of programming language are C++, Java, Python, and MATLAB. algorithm, we can use CNN or RCNN. Image capture method, which we can choose scanner, camera, or download from internet. Image transmission, we can choose Wi-Fi, USB cable, or Bluetooth. The objects which we want to identify are regular shape objects, hair, or neurons. We can get four alternatives. We want to know which alternative is good, so we use speed, easy to use, image clarity, precision, and convenience to evaluate them. Because CNN algorithm is slower than RCNN, so alternative 3 lose some point on speed. Because scanner is not easy to use, alternative 3 and 4 lost some point on that. Image clarity, that the image captured by scanner is better than image which is taken by camera, and the image clarity of neuron is better than hair. Precision, using scanner and neurons will get better precision. Using Wi-Fi and camera are more convenient than using USB cable or scanner. So finally, we choose the first plan, which used MATLAB as our programming language, use RCNN algorithm, use camera to capture image transmission, we can use Wi-Fi, and the objects we want to identify are neurons.
Now let's talk about the pairwise conversion of this kind of elements in the programming. And as you can see, the most important thing is that the precision. That means the accuracy of the program identify the elements in the image and counts the number of it. So our program's function is that to do these things accurately. If we cannot do this as good as possible, so the program is useless. And the second important thing is that the variation. Variation means the program can identify other objects with getting some training. So that's why we use machine learning, and the machine learning can let the program learn itself. So so the method is important. And the third important thing is that image clarity. That means that's the image which inputs as clearly as possible. So if we can get some clearly image, so we can let the program to identify and count the number easily. So that's also important. But the speed, the easy to use, and the size of image is not so important as the three kind of elements, because that the computer's speed is very fast, so we should not worry about the speed. And so as easy to use, just we can just use input one picture and get one output. So the the usage the instruction is very easy. It's already very easy to do. So we should not about worry about how to use the program. And the size of the image is that we should the biomical image is not so big. And if we uh, also if we get some small image, we can process it. If we can get some big image, it will more clearly, so we can imagine it better. So we should not worry about the size of image.
This is a black box diagram. As a user, you only need to input images and wait several minutes. Then you get the number of hippocampus in your image. Next slide, we will introduce the transparent box diagram. First step, you need to input image, and then you will get a you need to set a filter to do convolution of the images. For and we use the region proposal network to process the convolution feature maps to get the region of interest. In this procedure, you need to slide windows to get the whole region of the interesting, and you will need to pull the ROI and only classify the objects in ROI. is region of interest. This will increase the speed of our program. And at last you will get the result. In this slide, I will introduce the convolution neural network structure. And if the the size of your input image is 28 times 28, and the filter will be 5 times 5, and your feature map will be 28 minus 5 plus 1 is equal to 24. And then you need to pull the feature map and repeat the previous procedures. And this means there are two convolution layers. Then we fully connect the pulled feature map. For example, if the size of the feature map is 10 times 10 times 150, you will get the 1 times 15,000 feature maps. And in the softmax layer, you will get the probability of your result.
Let's talk about our budget of our senior design. Our work is mainly about the software design, so we do not need to worry about the hardware. And of course, we will not spend lots of money on buying materials, but we may need a camera to capture the image of some kind of evidence to test and teach our program. So our budget will not exceed $100.